Hey guys, it's Al. I'm here at the Haas factory to talk to you about how you can use Fusion 360 and your Haas probe to increase process reliability. It might sound innovative, but really it's just about creating a conversation. Just like we created a conversation in the early days of our relationship to ensure we had quality post-processors for every user that was using both a Haas and Fusion. Now we're talking about a conversation where what's going on the programming side of things is connected to the machine, and we're getting data back into that program to create a conversation almost. Think of it the same way as you would have as a manual machinist, taken a cut and come in and measured it and then adjusted and taken a cut. You had a closed loop, or almost a conversation, a closed loop there. And we want to use our probe to have a closed loop system, and again, that's going to increase our process reliability so that if the operator's tired on a Monday morning or ready to leave on a Friday, we're going to get a consistent part out of the machine. Okay, so we have this little part we're going to use to demonstrate a few concepts with probing in your NC program. It's left with a very typical problem. I like to call it a top hat, but we've held it in a vise in the first setup, and that means when we flip it over, it actually hides all of our critical features, so we can't really see them and access them with a probe from the top, but that's okay. Our first probing operation is actually just going to be to make sure the operator put the stock in right and center it close enough that we don't crash our face mill when we come down. So the operator will put it in anywhere within ½ an inch. That's fine because the probing cycle can kind of look. If it doesn't find the stock, the program won't go on, and if it hits the stock too soon, the program won't go on. So we catch some reliability here if for some reason the operator did it wrong. Now there's another thing I want you to look for, and this is going to happen every time, but just this first time, take a look. When the probe comes down, you'll see it pause for a moment. That pause is where the probe is moving into what we call a protected move. The protected move means if the probe ever touches something, while it's in the protected move, it's going to stop if it wasn't expecting to touch something. So I hope that gives you a little bit of confidence to go ahead and program this machine. We've got a protected move, it's going to stop, you can't crash it. It's the one tool you can't crash, you really shouldn't be scared of using it. So we're going to come down, we're going to probe it, we're going to find out where the stock is, and then we're going to keep moving on. One other thing you can look at when we're running it is on the control, you'll see a little error and size thing right down here in the bottom. That's the other piece you can look at to see how much we are off. So a couple little details to look at. Look at when it pauses and goes into protected move. Look at the control when it's showing the error that things were off by. So that first probing operation finds where the part is. The next set of toolpaths you're going to see are going to start to remove the top hat and expose the bore. Once the bore is exposed, we're going to call the probe again, and it's going to come in and now accurately find the location of the first part, the first op, sorry. The first probing operation we did was located off of saw cut edges. So that's not very accurate. We really want accuracy, both for the bore and to be honest, for the little chamfer. It's just a 5 thou chamfer. If this is misaligned, even by 2 thou, the chamfer on one side is now 7 thou, and the chamfer on the other side is 3 thou and tiny, so you'll visually even be able to see it, even if the part's within spec. So we're going to use that bore to locate this back side to the front side. Once it's located, we're going to come in and we're going to start to machine the critical features. We'll chamfer it, we're going to take a semi-finished pass on the bore, and this is where our next probing operation comes in. So that semi-finish is going to be a pass that leaves 5 thou of stock. Much like when you're manually machining, you might take your second to last cut, leaving 5 thou, you'll measure your part and then accommodate the cut accordingly so that your final pass is the same as the pass was just before you measured. So we'll go ahead and we'll measure that. We'll adjust the cutter comp. Again, you want to look on the control and see that cutter comp adjust, and then we'll do a finish pass around that bore to get it right on size. And finally, I'm going to show a neat little trick how we can use the probe to measure the part, and we'll get the data out and we'll look at that data in Fusion. Along the way, you'll see us use the fan to blow the part out to make sure when we're probing it, just like if you're measuring manually, you might use a rag or something to clean the chips and the coolant off before you measure. We'll do the same thing. We're going to use the fan to blow it off instead of an operator having to lean in. So I hope you learned something. I hope it's exciting for you. It's really exciting to me to start to create this connection in the NC programs. Okay, it's time for me to find out if I can walk and chew bubblegum at the same time. What we're going to try and do here is that you see a couple feeds will bounce back and forth between what the predominant feed is, and while the part's running, I'll try and explain some concepts in Fusion, and then we'll put the focus on the machine when we get to those probing operations. So let's go ahead and start the program. And I want to first bring the attention, thank you, bring the attention to the control here. You should see that we're running macro cycles. And to be honest, I wouldn't know how to write this. The post processor takes care of this all for me. I don't need to know any of it. And we're going to show you that in a minute in the software. And then the other thing to take a look at is right down in that bottom right corner, you can see the size and the error. When we run this probing operation, you'll see those values update. And this is going to update each time we run the cycle. There was some specific settings I set for that, and maybe I can show you that later as well. While that's running, we have a few minutes, so let's put the focus on Fusion. The focus of this video is probing, so we don't need to watch the machining, but you can go ahead and do that if you'd rather. I'm going to spend some time in Fusion and show you around there. First little call out here, though, I got to give a quick thank you to my colleague Richard Stubley over in England. When I got to the factory this morning here, there's a few extra vices on the table, and I took a quick picture of the setup, and Richard was kind enough to work in my model here for me and model those extra E-vices there. Pretty exciting to see what Haas is doing here on programming vices too. So again, thank you, Richard. I see your little red dot on there, so you're still in the document here with me. Let's do this. The first thing I'll show you, though, is on the NC program here. You can see my first operation was that probing cycle. That's the one that we just watched. Probably be nice to show you how that works. Now, when I did the stock, I always like to model the stock. If I go ahead and expand my models, I can turn on the stock body for the model. That stock body on. To add a probing operation, we simply go to the inspection tab. We'll set work offset probing. And from here, I just select the geometry that I want to probe. In this case, I want to find the center between those two faces. So when I select two faces, that's going to give me a probing operation to capture the center of that. So that happened automatically for an X wall. You can see here that we've got some errors that can throw if we're too far out of position, which I'd mentioned in the beginning. But that was pretty quick and easy. It's going to automatically throw out that cycle. Again, I don't even know how to personally program with those cycles. I'm fully dependent on the good work of our post team. The other piece that I thought might be useful is just making sure you have the right post processor. So let's cancel out of this. On the post processor, that's all handled in this NC program. If you're not using NC programs, I'd suggest you check that out. I'm going to edit my NC program. And in the NC program, you can see I'm using this Haas post with support for inspection. If you want to find that post processor, you can just go ahead and hit choose from library. When we choose from the library, you can search our online library. Just go ahead and type in Haas. I could spell on these live videos here. So I type in Haas. You can see all those libraries we've been working together on. And in those libraries, you can go ahead and pick your next gen post. In this case, I'm using the one that can inspect the surfaces for later on in the video. So we've got that post. Maybe one other quick thing, quick little tip. I love this option. I wish it was on by default, but home position center. At the end of our program, that's just going to send the part in front of the door. And it looks like we're almost ready, so I'll go change that, and then we'll jump back in. Just give me a minute to change the part.
Okay, on the second the second setup, the first two probing operations are again just work offset probing. So we don't need to look at that again. By the way, you saw that neat little trick where we can sync the view, so we flip the part around and saw our other side. So again, we're going to probe the stock again. It's looking at the saw stocked size, so roughly getting into shape. We're seeing those operations remove off that top hat and plow into the bore there and expose the hole from the other side. Again, it's just a work offset probing operation coming down into this hole. We're going to next semi-finish this. Remember I told you earlier that we want to leave a little bit of stock, so if I look at that operation, we have a stock to leave of 5/1000ths of an inch, and we also have a 5/1000ths of an inch step over on our finish pass. So that means the final pass is going to be the same after we accommodate for the probe. Let me show you how that probing operation goes. Oh, this is super interesting. First, it is in the machining extension, so just a quick note. It does require a purchase beyond Core Fusion, so we need to go ahead and purchase that. I'm just going to go ahead and select the extension. You can buy it for the entire year. I think that's what most users do, but if you'd like, you also do have the option to just go ahead and purchase it for a day if this is something you just want to use on a specific project. So I'm just turning it on, showing you how quick that works. That's just turning on extra functionality for the day. Inside of this toolpath, if I edit that toolpath, this is where things get a little more interesting. You can see, same thing, we picked a probe, similar definition as the work offset probing. But in the case of the last tab, the Actions tab, we actually get the opportunity to do this probing operation based off of another toolpath. So you see I selected the previous finishing operation. I'm just going to go ahead and delete that and show you how I did that. So all I had to do is go to that finishing operation that machined that stock. It recognized what tool was used. It recognized that there's 5/1000 stock to leave. Lets me set a threshold. It's that simple. There's a few other things. We could send an error if it was out of position or the wrong size. In this case, we're telling it to update the tool wear. So I think that's pretty interesting. It certainly makes it easy for somebody like me that has long since forgotten how to write some of the specifics of G-code. So that's the next operation. Let's keep an eye out now and see when that runs, just so we can watch this happen. So I'm going to go stand in front of the machine and we'll try and talk you through it. So here we go. We can now see the probe getting down inside of that bore that we couldn't access before when we first flipped this part over. We're setting the Y direction and the X direction to get the backside setup here perfectly aligned with the top side setup. Of course, that's going to mean the bores are concentric, but remember that also means the chamfer that's going around that profile that was machined from the other setup is also going to be perfectly matched. Sometimes it's hard to think about, or we don't think about it, that again, that simple little 5/1000 chamfer just being off by a few thousandths of an inch is going to be very visually unappealing. So it's great to be able to reference the second side from the first side. I've now got my Haas fan coming across to blow the part off. I thought that was a great trick to make sure all the chips were out of the way so that when the probe comes in to measure this bore for size now, that's the next probing operation. We're coming in and we're checking the size of that bore that we just machined to update the cutter compensation or the wear offset on that cutter. So we're now pinging the bore that we just machined. That's going to update the cutter comp of the cutter, and then we'll come in and remachine it and get it bang on the right size. So we're back to machining. Let's hop into Fusion while this is going. Maybe even want to see how we do the fan program. So programming the fan is actually pretty simple. I just use a facing toolpath. So let's just click face. For my tool, I have a very large, it's defined as a face mill, the diameter of the fan. Typically the facing operation is going to run right across the top of the part, and I'm simply saying instead of model top being where it's going to run from, I'm just going to come 6 inches above that. For the top height of the tool path, I'm just going to make that the same height as the top height of my, or sorry, the bottom height of my previous tool path. So they're just all at the same height. The retract height is just going to be referenced from the feed plane, and maybe we come 2 inches above that. Another quick little trick we can do is go to the pass. I used a pass extension, and I shot it out 6 inches too far on either side. And that gives me a pretty simple tool path to run across and blow the part off. So hopefully that's a neat little trick for you. We want to drag that into the right spot there, but that's how we went ahead and did that particular tool path. The last tool path in here that we're going to do is measure the part. It's a pretty simple one. It's just an inspect surface. Inspect surface is on the inspection menu as well. What we can do with this inspect surface tool path is actually drop points exactly where we want to measure. I could add some other points, and it's going to capture those measurements right on the correct spot, and just go ahead and log it. There is one thing I should point out just while we have a minute. On this particular NC program, the first time you use the inspect surface post processor, if you're going to do surface inspection, you do need to use the commissioning mode. You just got to run that once. It's going to walk through some checks. You'll have to hit cycle start a couple other times, but just check that out. There is a little commissioning mode that you'll use the very first time you use inspect surface. In a minute here, we're going to look at what the results look like coming back from that inspect surface, as well as the operation where we probed this bore. We're going to pull both the data from that probing operation and the inspect surface back in. So we'll get this part out of the machine, and I'll be back in Fusion in a minute here to finish things up.
With the part done, we can load our results into Fusion 360 to look at the results, and we can even capture some additional measurements using manual measure and our Bluetooth calipers.
All I'm doing here is clicking the input button on the calipers as I make the measurements. You can see Fusion walking around and guiding me to each measurement that's necessary. Double check this bore that I wanted so accurate. Let's see how it goes. Oh, we got it. And finally, I can do a visual inspection for those chamfers. And then we can look at the results. I did import the results earlier from the probing operation, but we can look at the results that combine together both the data coming off the Haas control from the probing cycles and inspect surface, as well as the data we just got from manual measure.
Well, I hope this short video inspired you to start using your Haas probe in Fusion 360 to capture intelligence in your NC programs. If you're new, I'd recommend watching the Haas Getting Started videos on using the probe. And if you're ready to take it to the next level, check out our Best Fit videos. Thanks for watching.